Hi, welcome to Everything Embedded. In this video, I want to talk about the file system partition, which gets created on the micro SD card. So when you use Yocto to generate an embedded Linux image for your Raspberry Pi, it creates two partitions as I discussed in the last video. One is the boot partition, which I covered in my last video. The other one is the file system partition. So in this video, we are going to be talking about the file system partition. So I have inserted my micro SD card into the Ubuntu machine. Let us go and explore the contents here. So here are the two partitions. So this is the file system partition. You can see all the Linux folders here. It's the standard Linux folders. And the other one was the boot partition, which we have seen in the last video. So we'll not be covering that. So let's talk about the file system partition. So before we go into each folders, let's look at the property, the size of this partition. So I'll have a look at the property. So it has occupied a space of 1.2 gigabytes and the free space is 1.1 gigabytes, which is not much. So which means if you have any application which are going to be running from inside this partition, they will not be able to, the disk space is quite limited. So what to do if you want to increase this free space? What I'm trying to say is, what should you tell Yocto? I want more free space in the file system partition. So what exactly has to be done? So I'll just show you now. So if you go to say open, I'll go to my local.conf, so where my Yocto is installed, and have a look at the script here. Minimize that. So there is a variable. I'll try to zoom in on this one here. There is a variable called as image root fs extra space. So in my case, I have set and that takes a value in kilobytes. So I have set the value here of 1048576, which is about 1 gigabytes. So this way, this was my way of telling Yocto that I want you to generate an image with the file system which has an extra free space of 1 gigabytes. Depending on your needs, you may want to change it. So for example, if your micro SD card is 64 gigabytes, you may want to allocate everything to it. So you can just say 60 here. So that should give you a 60 gigabytes of free space, which your application may need once it starts to run. So this covers the free space part of it. So this is how you control how much free space you get on your file system partition. So let's close this. And so here are the files and the folders, the standard Linux folders, as I should say. There is nothing special about the names of these folders, as most of us know. Let us look at the contents, and just so I'll explain where what comes from where. So this has all the standard Linux, not all, whatever we have defined, and you should get all the binaries here. Again, just since this is a beginner video, and also since it makes sense, what I'll explain is how do we get these files, or what kind of files come onto the file system partition is controlled from the image definition. So let me go to my image definition. This is again in Yocto. So this is where I have defined what kind of packages I want, whether I want SSHs, whether I want all the libraries which are related to the sounds, all the extra tools. As you can see, I am using bzip2, DOSFS tools, find utils, grep. So this is where I have defined them. These are the binaries which I need in my final embedded Linux image. This is where you define them inside the image definition. I hope this makes sense. Should be easy to follow. And these were some of the demo programs which I wanted to build and which I also wanted to be included in my embedded Linux image. And again, these are the various binaries here. Again, something to do with the development, some security tools, all the Qt packages, some font utilities, and some security tools as well. And this is where you define them. And when you go onto your, let's go to the file system. So here we are in our file system now. This is the binary bin folder. Here you can see it has all the binaries which we asked Yocto. So Yocto has made sure that we get all these binaries here. And is there anything in this folder? No. What about the dev folder? Nothing here. etc. So we have some fonts, everything which we have, which was required, which we asked Yocto. And what other can we? Let's look at the sbin folder. So again, this has all the various tools and utilities which were configured to be used in the image file. So everything is here. Hopefully this makes sense really. And again, should be easier to follow now. Whereas nothing here. Anything here? No. Yeah, and what I think that should cover what I was trying to cover in this video is what are the files and folders which get copied. And in my case, my script, so this is a folder called as OPT folder. Remember, we are talking about the file system on the generated embedded Linux image. Now there is, in the OPT folder, I have a folder called as coffee place, which has a binary folder and the binary itself. Now, how did I put this here? I mean, what did I have to do in Yocto so that this file was copied here? Again, I'll take you back to my scripts, to my Yocto scripts. So if I open, I have a recipe called as a coffee place. And if I go into that recipe and let us look at the recipe itself, this should make it simple what exactly was being done inside the recipe in order for the coffee place folder to be created in the OPT folder. Let's look at the recipe of this file. So here you see, this is my coffee place script, a script called as coffee place. And there is a method called as do install append. I'll zoom in on this part, which installs the binary in the OPT folder here. So as you can see, that's where it gets installed. And this is all done by this script called as coffee place and a method called as do install append, which gets called once your recipe is built. And since this was a Qt project, I had to inherit it from QMake. I hope this makes sense. So I'll keep it simple in this video. So what gets generated in the file system folder comes from the recipe files. Whatever you put here is what you will get in the file system folders. So, and I close this one. So this is my file system folder. I have the files here, and yeah, hopefully this video I will should have given you some idea what is a recipe file, what are the two partitions which gets generated on the micro SD card, how are they controlled, and what do you need to do in order to increase the free space on the file system. Thank you very much for watching my video. I'll see you shortly in the next one. Cheers. Bye bye.